Welcome back again. So today we will be going on with masterminds. In the last video, we did task 1 and task 2 where we navigated through the infection 1 PCAP. We discovered that there was an infected machine and we provided the IP address of the infected machine. We provided the web activity of the infected machine, and finally we arrived at the point where we determined the type of infection the machine had. So basically, we use Brim to analyze the network traffic and do forensic analysis. Now, in this video, we will be doing task 3. So in task 3, we will be following the same methodology. We will use Brim, load a PCAP file called infection2, and do or conduct forensic analysis on the machine. So the first thing you have to do is to start the machine, and don't forget to click on split view from here. It would appear here before you click on that. After you click on it, you will be able to see the machine here. So then click on view in full screen to be able to view the machine like that, and minimize the view here so that you are able to answer the questions and at the same time analyze the PCAP file. So once you open Brim, we choose files, import the file, go to desktop, PCAPs, and we have infection2. So now once you double click on that, the PCAP file will load. It's going to take some time depending on the file size, and eventually the file will load and you will be able to see the data on this interface. Alright, it seems that it is completed now. Now, as we spoke in the last video, guys, we have gone over the fields here, and we know that this column is for the source IP address, right? And on the right, we see the destination IP address. So let's take an example. Here we have in this example here, we have an HTTP request. The source IP is 192.168.75.146. The destination IP is 1.5.181.156.252, and the protocol is HTTP. The method is post request, and this is the URL. This is an example. If you want to understand the basics, just go back to the last video I did, Network Forensic with Brim, part 1, to understand how the program operates. Now, I'm gonna go to the questions and start directly. So provide the IP address of the victim machine. All right. So the victim machine is the machine from which the PCAP originated, right? This traffic happened on the infected machine. So most probably the most occurring IP address in the source column is the victim machine. Let's see what is the most occurring IP address here. Normally, we have to do that through some sort of mathematical formula to understand the counts of every IP address like we do in Splunk. But here, let's see what are the available queries. Maybe that would help us understand more about the victim IP. So we have show IP subnets. Let's click on that. Okay. Unique network connections. So as you can see here, 192.168.75.146 is an internal IP address, right? And if we click on that, if we go to columns, see what are the available columns. So we have only these 3 columns. That's fine. Let's see the view. Nope. Okay. So this IP address is the IP address of the victim machine. Seems to be the closest one to be the IP of the victim machine. For two reasons, for two reasons. The first one is it is occurring very much at the same time. it is internal, right? And he received the IP address of the router 75.1. That's the gateway of the network. So let's answer with this question. 192.168.75.146, and that's correct. Okay, let's get back, delete the query, and click on search one more time. So now you have determined the IP address of the victim machine using the queries on the left pane. Let's see the second question. How many post connections were made to the IP address in the previous question? So here we have to look for the HTTP post requests made to the IP address, which means the IP address here has to be the destination IP address. So now we are getting more familiar with the situation. It seems that the victim machine was acting as a public server. In this case, it seems to be a web server. Oops, I have jumped to the third question. Actually, I have to do this question. Provide the IP address to the victim. Provide the IP address the victim made the post connections to. So here, the victim made post requests to some IP address. We have to provide it. So on the left pane, we have HTTP requests, and also we have HTTP post requests. If you click on that, we get 3 results. And the 3 results, as you can see here, originate from the same IP address, the victim machine, and the destination is some IP address, right? The method is post request and the traffic is on port 80. So we're tasked to provide the IP address the victim has communicated with over port 80 with post request, which is this IP address. Okay, now we jump to the third one. How many post connections were made to the IP address in the previous question? All right. Now I think I was confused in the situation. So basically, the victim machine is not a public server. Here we have to provide the number of post connections made to this IP address. It seems we have only 3, right? So 3 connections. Provide the domain where the binary was downloaded from. So we have an executable file, probably an executable file, let me say, downloaded from some domain. We have to provide this executable file or domain or binary file. So let's again go over the traffic, click on HTTP requests. So the victim has made a GET request to hypercustom.top to retrieve a file called API-NES.exe. So the executable file is considered basically as a binary file. And since in the question we're asked to provide the domain name yes, from which the binary has been retrieved, we can answer with this domain name. Let me see if this is correct. Yes, it is. So next one, provide the name of the binary including the full URL. So here we have it. Provide the IP address of the domain that hosts the binary. Provide the IP address of the domain that hosts the binary. So this is the binary. This is the domain that hosts the binary, and this is its IP address. Very simple and easy. There were 2 Suricata network Trojan was detected alerts. What were the source and destination IP addresses? So now we jump to the IDS alerts. And that's one feature Brim has, which is the integration with Suricata logs. You can integrate Suricata logs, right, or IDS logs with the program, so you can correlate data between or from different sources. So now, 2 Suricata network Trojan was detected. Let's go Suricata alerts. Click on So we got alerts by category, by subnets, by source and destination. Let's click on source and destination. So indeed, we have a network Trojan was detected, potentially bad traffic, 2 events. What were the source and destination IP addresses? Let's look again. So the first case, the source is the victim, destination is some IP. The second case, the source is also the victim. The destination is an internal IP address. So what were the source and destination IP addresses? Okay, so the first one is the internal IP, a comma. Second one is this IP address. Taking a look at .top domain in HTTP requests. All right, provide the name of the stealer, Trojan that gathers information from a system involved in this packet capture using URL house database. Clicking on that. Okay. Now, if we go back to the HTTP requests, this is the domain name. So here, taking a look at the top domain, provide the name of the stealer involved in this packet capture using URL data house. The first time I see this URL house is a project from abuse.ch with a goal of sharing malicious URLs that are being used for malware distribution. Okay. So I suppose here we search, right? Domain, URL, MD5. Okay. Let's search with this URL. Maybe we have something. And don't forget the domain name. Search. Yeah, indeed we have a match. So provide the name of the stealer. If you click on that to get more details, we see this is the host domain. And also we see the tags. In the tags, we have cryptbot, open directory, redline stealer. So basically, we got the answer. So the answer is red line stealer. And that was task 2. So task 2 is kind of similar to task 1, right? You are investigating an internal machine that was infected with a Trojan, a virus, malware, whatever you want to call it. Now let's take a look at task 3. Let me see if we can do that in this video or we have to do it in another video depending on the concepts. So we load the infection 3 packet capture. All right, provide the victim IP, provide the 3 C2 domains from which binaries. It seems to be similar to the last 2 tasks, so let's do it in this video. Okay, so we're done with this one. Now let's load the infection 3 capture. Choose files, desktop, PCAPs, infection 3, and we wait for infection 3 to load. So the first question, provide the IP address of the victim. Second question, well, this one seems to be tough, but let's see. Provide the 3 C2 domains from which binaries were downloaded, starting from the earliest to the latest in the timestamp. Provide the IP addresses for all 3 domains. All right, let's see. First question, the IP address of the victim. So let me click on, see here, show IP subnets. Okay, so these are the subnets we have, and we have one here that seems to be an internal subnet, 192.168. And also, let's see here, what could be an internal subnet? Well, we have very good number of subnets. So this one also seems to be internal, 172.67. Okay, let's take a look now at unique network connections. No, not this one. All right. And again, we see an internal IP address, right? 75.232, communicating with different IP addresses. So the victim IP address is clearly this one. So 192.168.8232. Actually, it's not 8, it is 75. Okay, provide three C2 domains from which the binaries were downloaded. So we have the victim downloading binaries from C2 domains. We have to provide these domains. Click on HTTP requests. Oh my God. Seems many things were going on here on this machine. So the victim, unfortunately, downloaded 543215321 from this domain name, from these domains. That's one, that's two, and also we have this one. Okay, let's copy them. These are the domain names from which the victim has retrieved the binaries which caused the infection in the first place. Nope. I think we have to put the comma here. Yep. Provide the IP addresses for all three domains in the previous section. Okay. So here we have the IP address in this column for the first domain. And here we have the second one. Finally, for this one. How many unique DNS queries were made to the domain associated from the first IP address from the previous answer? So the question simply is asking how many DNS requests were made to this IP address. Okay, unique DNS queries. Do we have a problem in the machine? It's not responding. I hope everything is okay. All right, so unique DNS queries now, we get it. All right, so here you have only domain names, and we have to find out, okay, let's search with this IP address then. If we paste the IP address here, yeah, the machine is lagging. Now we paste. Okay, we search. Okay, let's see here. So looking at this column, we look at the protocols, the type of event. We see here two DNS requests were made from the victim IP address, right, to this IP address. But why these events are here if they don't include? So we have it here. Okay, two. How many binaries were downloaded from the above domain in total? How many binaries were downloaded from the above domain in total? Okay, so this IP address is associated with this domain name, right? Now, if we go to unique DNS queries, the one that starts with X. If you look with the one that if you look for the one that starts with X, definitely not this one. Scroll down. So RU. So it is RU. The extension is Russian extension. If you have very long list of domain names, searching this way would be hard. But still here we have, because it's short, we can handle it. Now here we have two. How many binaries? Oh, not DNS request. So here, yeah. How many binaries were downloaded from the above domain in total? So let's copy the domain, and maybe we can use the search menu to display all of the events related to that domain name. Again, we have some lagging in the machine. No idea why this is happening. Copy, paste here. All right, search. How many binaries? Let's count. 1, 2, 3, 4, 5. Provided the user agent listed. It is provide, not provided. Provide the user agent listed to download the binaries. Okay, I think here if you look at the fields, we can find the user agents. So we see this column includes the user agent, which is Mozilla /50, and we have the details. It is on Macintosh machine, which happens to be the victim machine, by the way. Provide the amount of DNS connections made in total for this packet capture. So now we have to find out the total number of DNS requests. It doesn't matter to the machine, from the machine, all right, made in this packet capture. So maybe if we go to unique DNS queries, we can sum the total some way. So here you have the numbers, right? So now we have to find out the sum of these numbers, right? Yes. Made, yeah, for this packet capture. So sum all of these. Let's look for sum function, Brim sum numbers. Brim network forensic. You want to know how to sum these numbers. Okay, let's see here. Path equal DNS count by query. Sort. Okay, put pipe here. Sum count. Let's see if this works. Okay, so it is 986. 986. With some OSINT skills, provide the name of the worm using the first domain you have managed to collect from question 2. So here it's saying that this domain name is used to spread worms. Find out the name of the worm. Please use quotation marks for Google search. Don't use RU in your search and don't interact with the domain directly. Okay, let's take this one and get the help from task 2. Go to this URL house database and see if there is some hits on this domain. None. Okay, now we have to use Google in this case. So let's cancel the RU as instructed by the question. So any run has one result, sinkhole. Click on that. This is our domain name and this is one of the executable files. Malicious activity. If we go through the report to understand more about the infection, here we have screenshots. Okay, so that's how it works. So first we have the start from the Internet Explorer. The victim downloads the file and executes the executable file. Here are the events, registry, dropped files, network activity, connections, DNS requests, threats, network Trojan. Okay, what is the name of that? And why it is called sinkhole? Trojan sinkhole. Let's see here. Sinkhole. Nope. Okay. Let's click on this one. It is a sandbox. And here we have the engines that reported the results. Evader. These are tags. But now we have to find out what is the name of this. Goozy. How many characters in here? 1, 2, 3. Okay, it seems like a relatively long name. Let's type worm. For fix trick botnet campaign leads to multiple infections, ransomware, banking, Trojan, and cryptojacking. Let me search with the domain name. Maybe we can understand more the context of this search. Okay, so the obfuscated script launches the Windows script host to leverage PowerShell. It downloads APXPacked portable executable named good from an IP located in the Russian Federation. Then pulled the payloads from these domains. So maybe this is the answer, the name of the worm. And finally, so we finished now this room. It was fun room, and most importantly, you learned how to use Brim to conduct network forensic on packet captures taken after you take them directly from the victim machine. So basically, this is the scenario where you are an incident responder, right? You interact with the victim machine, take a packet capture of what's happening, and then send that to the network forensic analyst to understand more about the behavior of the malware that infected your machine in the first place. So that was for today. I hope you enjoyed the video and see you later.